Welcome to the Windows Azure, What You Need to Know About Moving Your Apps to the Cloud webinar. It's going to be presented by Andrew Coates. So Andrew is a Developer Evangelist at Microsoft, so there's no one better placed to discuss the benefits and pitfalls of adopting the cloud as your platform. So without further ado, I'll just hand you over to Andrew now.
All right, so welcome. Thanks for joining us, everyone. I do appreciate taking some time out of your day to think about Windows Azure. So this is what we're going to chat about, I'll quickly run through sort of why the cloud and why Azure, and then we'll talk a bit more about moving to Azure and the sort of things that you need to think about, and maybe some of the pitfalls that you might come across. I've got a list of resources, and so that first section should take around, hopefully around 20 minutes. So hopefully we'll finish that by just before 11:30. And then we've got another half hour or so for Q&A. And then I often find that some of the most valuable stuff comes out of that. I can give you a fairly generic overview of things, but if people have burning questions, it often triggers off some quite useful conversations. So please do stay around for Q&A and ask some good questions. While we often think of the cloud as the Azure piece or the Amazon Web Services piece, or even potentially the Salesforce piece, the cloud is lots and lots of other things. So the cloud is Xbox Live, the cloud is search, the cloud, and lots of us are using all of those things in production. So while no one answered they're using the cloud in production, I would submit to you that you probably are if you're using Gmail, or if you're using Hotmail, or if you're using Xbox Live or any of those things, then you probably are using the cloud in production. But we're particularly talking about the cloud that you can program it and administer yourself today. And we'll talk a little bit about the continuum of what the cloud looks like and the patterns that are there. But really, the cloud is all about scale. I think it's the important thing to know about the cloud is that it's scale in a number of different ways. The first place that cloud is important is the fact that you get a huge benefit from the economies of scale of us providing data centers and looking after them. A couple of quick stats there. The Gartner guys reckon that a cloud data center is something anywhere from about 250,000 servers up. And really, to be economical, you want somewhere in the order of 500,000 servers, and you probably need at least 2 data centers, so you've got geographic redundancy. So now you need 1 million servers. That's a not insignificant number for most people of servers, and there aren't very many organizations in the world that can provide that. But if you can, then the benefits you get are manifold. The first one you get is you get a huge benefit in terms of being able to actually buy the hardware. If you go to HP or Dell or IBM and say, I need 100,000 servers, they're likely to give you a reasonable price. So we reckon it's about 30% of what you'd pay for a commodity hardware off the shelf. And so there's a huge savings straight away in terms of scale. You also get a huge benefit in terms of the efficiency of the servers and the power distribution and the racks and those sorts of things. So again, we reckon there's about a 20 or 30% benefit there. And the other place you get a huge efficiency is we have a ratio of about 1 admin to about 5,000 servers, maybe a few more, maybe a few less, but it's in that order. Whereas I think that most organizations have 1 admin to, I don't know, maybe 50 servers, but more likely to be in the order of 10 or 20 servers. And so we get at least 2 orders of magnitude benefit out of being able to run these things in the cloud. And of course, all that gets passed on to the end user. The other bit of amazing scale benefit that you get out of the cloud is that we can afford to bring the very, very best people into organizing and running the data centers and all of the security bits and so on that go around that. That means that not only do you get the benefits of the scale in terms of the dollar value, but you're likely to be being protected at a better level than if you were doing it yourself. So the cloud is a very important part of that. Now, the cloud is also important in terms of scale in a different way. So the first one is the scale of the data centers and the ability for us to provide those at a very reasonable cost. The second one is that the cloud allows you to turn on and off the computing that you need as you need it. And so let's look at some of the patterns that you might use for cloud computing. The first one at the top there is this concept of turning the compute or storage or whatever else you're doing on and off as and when you need it, only paying for it when you need it. So a great example of this is the guys at Westpac. Each night at Westpac, they run some fairly serious modelling runs, as you'd expect when you're doing trading of shares. You want to have a pretty good idea about what's likely to happen the next day based on time series analysis and among other things. And to do that, they run complex financial models, and they run them a number of different models to compare results, and they run them based on a number of different scenarios that might happen during the next day or week or month. And they used to run that in-house, and they run it in a data center in-house, and every night they'd run this model, and they had, let's call it 500 servers to do that. Now that was fine, and they were pretty much at capacity every night to run those things. That was fine until something strange happened, or something unpredictable happened, like, I don't know, the Japanese buying back all of the yen and completely changing the models for things. Now, if they thought that might happen, and they wanted to run a model against that, they had to replace the model they would normally run. What they can do now is they can say, well, we actually run all of our modeling on Azure overnight, and we turn it on for the 8 hours that we need it, and we turn it off, and we turn as much of it on as we need to, and then we turn it off again. So some nights they might only turn on 100 servers, some nights they might turn on 10,000, whatever the number is. That sort of order of magnitude is available to you in the cloud, and so it does mean that you can very quickly use the computing power you need and not use it you don't, and only pay for the stuff you need. The next one is this concept of growing fast. This is the typical startup. One of the most difficult things to do when you're growing fast is to keep up with your demand in terms of provisioning hardware, and bandwidth, and network, and all those sorts of things. Often, it's just not possible to physically source the hardware and install it and make sure that everything else is in place. And the great thing about the cloud is that we've done all that stuff for you, and if you need more in a hurry, we can give it to you pretty much straight away. And so as you grow, your infrastructure can be taken care of. And when I say we, I mean the cloud providers. I'm not specifically talking about Microsoft here. These are very generic cloud patterns. The concept of unpredictable bursting is another really interesting one. And a great example of this is somewhere like emergency management. So for the Queensland floods recently, for example, the emergency management site was set up, and of course it was very quickly going to be overwhelmed. So what they did was they set up an Azure site to do this, and it meant that they could provision very quickly another 30 servers, and only keep them up for the time they needed it, and then go back to their base load, which may or may not be running from their local data center, or might be running a couple of instances up in Azure. Now the neat thing about this is that again, if you have an unpredictable burst, then being able to provision hardware for that quickly is very difficult, and often very difficult, particularly difficult if you're in an emergency situation, obviously, because there are all sorts of other considerations being taken into account around availability. But using a cloud provider for that makes that very, very straightforward. And the last one, of course, is this concept of predictable bursting, and that the time scale on that bottom graph could be anywhere from over a day to over a year. A great example of the annual sort of predictable bursting is the guys who do the tax returns. You may, if you need that to happen on a regular basis, that might be your quarterly BAS return, or it might be your annual tax return sort of timescale there. Or another example of something that spikes very, very sharply is things like, well, Domino's Pizza in the US is a great example of something that spikes very, very sharply. One day a year, they do more than 10 times the traffic of any other day in the year, and that day is Super Bowl Sunday. And for that day, they basically reroute the DNS from their on-premise server, which normally serves their on-premise in their own data center, which serves their day-to-day use, and they reroute it to a set of Azure instances where they can ramp it up very high. And that's another great example of that. And they can plan for that, and they ramp up and they ramp down as they expect. But it's a very cool way of doing things. Now, this is not to say that every cloud, every time you use the cloud, every time you have an application, you should use the cloud. And one of I'm going to call out a couple of places where cloud compute doesn't work, or it makes more sense to think about doing things a different way. This is one of the ones here. My brother-in-law happens to be a director of IT at UNSW. But before that, he was the director of IT at the Faculty of Medicine at and they have a great facility there called online microscopy or virtual microscopy, where they have all the pathology teaching. You would used to happen through microscopes looking at slides of pathology. They now have online, and people and their students can be guided through a view of, what does a cancer cell look like, or how do you identify sickle cell anemia, or when you've done an excision of a melanoma, how do you check whether all of the margins of the excision have been appropriately clear of cancer, all that sort of stuff that all pathologists need to understand and learn. They can now do through a set of virtual microscopy. And this basically consists of large amounts of data, image data, and the ability to zoom in and out very quickly and display the appropriate tiles, a bit like a deep zoom. Now, at the first, they thought this would be a great cloud application. They need high bandwidth, and they need lots and lots of storage, and they need to be able to serve it to a number of hundreds of people at once who are in the class. But they decided in the end to keep it all on site, and the reason they did that was because that they weren't actually going to grow this data set very much, if at all. It was all going to stay. It was pretty much static. So they didn't need that fast growth. They wanted it on all the time. They didn't need to turn it on and off, so they didn't have this on and off concept. They knew exactly when what the capacity was for the bursting, and it wasn't enough to say that we needed to turn things on and off quickly. And they also decided that that most of their customers, most of the students, were actually on site, and they had a gigabit backbone or even 10 gig backbone up and down the university campus already, so there wasn't a lot of point of taking it off site. So they decided it wasn't an appropriate cloud thing to do. So there are times, I guess that's the moral of the story, is there are times when you don't need to put stuff in the cloud. Now we've seen these concepts of as a service for a little while, infrastructure and platform and software as a service. I like to talk of these as the pain and the as a service. And let's talk a little bit about what these mean. I think the best way to illustrate this is with a sort of comparison about where things were and where they are now. So cloud services in general are a replacement or an addition to the sort of stuff you'd normally manage yourself. Say you're running packaged software in your own environment. So the concept might be is in infrastructure as a service, the bottom of the stack is managed by the vendor, the bits in green. So the networking and storage and servers and virtualization is managed by the vendor. But then you as an application developer or as a consumer need to manage the operating system, the middleware or the runtime, the data and the applications. That's a fair bit of stuff to do. You've got to worry about things like patching. You've got to make sure that all the bits and pieces around applications talking to each other and redundancy are all taken care of, and so on. That's okay. It might be the useful thing to do. So I'm not making value judgments about these things, but I'm just saying that that's where things are. Now, this concept of platform as a service is we take it much further up the stack. We abstract away a bunch of the things that you would have to worry about as an infrastructure person, and leave only really what you need to worry about as a software developer. So up the top there, we worry about the applications and the data, and this obviously is the one I'm talking about most with Windows Azure, although Azure does do a little bit of infrastructure as a service. But this is a really neat place to be for me. As a software developer, I like the fact that someone else is taking care of all of the back-end bits, the bits that really are commodity. The bits that I write, the bits that I do, are the bits that only I can do. I manage the data and the application because that's the bit I understand and responsible for. The other bits somebody else can take care of, which is very useful. Now, at the far end, at the right-hand end of this graph, this slide, is this concept of software as a service, and there's lots of this around. The guys at Salesforce, for example, provide software as a service where basically it's not so much a platform you build on, although they do have a platform as a service offering to some extent as well. But the main bit of Salesforce is software as a service, where basically it's just an application that's running in the cloud. That you as a developer don't interact with, but you as an end user do. It's a very useful model. It means that again you can pay for only what you need, but as a developer it means you haven't got a lot of flexibility about what goes on. To me, as a software developer, sitting somewhere in the middle seems to make a lot of sense, but there are times at each end where it also makes sense. And Microsoft obviously have offerings at all these different levels. software as a service. We offer things like Office 365 and Hotmail and a bunch of other things where Dynamics Online and those sorts of things. So so that's definitely cloud offerings that are software as a service from Microsoft. At the infrastructure as a service level, we have the new VM roles in Azure, and we'll talk a little bit about those at the end. Although they're probably still a little way off coming to true infrastructure as a service. We might discuss that if we get a chance as well. But in the middle, the sweet spot for me is this concept of Windows Azure, where it really is a platform on which I'm used to building in terms of being .NET and IIS and so on, and it allows me to create applications that are scalable and resilient in a way that all of the details about the infrastructure are managed by someone else. So that kind of leads me on to why Windows Azure. And really, I think the big thing about Windows Azure for me is that it provides some core services that I'm used to using already. So there are a number of other services in Azure as well, and I'll talk a bit about where you find some more information about that at the end. But the core bits of Windows Azure are this concept of compute, which is essentially an IIS server or a set of IIS servers running in the cloud that allow you to deploy applications there and then serve responses to those applications and do compute things as though it was running on a Windows Server 2008 SP1 or 2008 R2 essentially are the options you've got. We have this concept of storage, which is a high capacity, fault tolerant, non-structured storage, where you can put things like blobs, where you have tables and queues. Tables we'll talk a little bit about later on as being different from database tables, where you have a concept of hard drives in the cloud. And then you have a fully relational database. And those are the three core pieces of Windows Azure, and you can see that they match pretty closely with the application services in IIS and Windows Server, the file system to some extent, and some of the file system services in terms of the storage, and then SQL Server on the right hand side in the database. And those three core pieces are there. In addition to that, of course, Windows Azure offers things like the Service Bus, which allows communication, but inter-application communication. It has the things like the data mart, which allows you to buy and sell data and applications on Windows Azure, and a number of other ancillary pieces that go on, including, I think one I should definitely mention is the identity services, which allow you to federate your identity into the cloud, either through your own Active Directory or through other identity providers like Facebook or Twitter or so on. So, or Windows Live, of course. So those three core pieces are the pieces that you're used to using all the time, and so I think that's one of the really big reasons that it makes a lot of sense to move to Windows Azure if you're going to move to the cloud. So I guess if you are going to move to Windows Azure, and I guess I'm making a bit of an assumption that you are, then we need to think about a few things. The moving to Windows Azure piece is really all about, pardon me, understanding where things go. I want to introduce some key terms, and I'm going to point you at some great resources about moving there, and I'll talk a little bit about some of the things you need to look out for as you do it. Often an application will have a front-end piece, which might be a web app, or it might be a desktop app which is talking to services of some sort. So your web apps basically get deployed pretty much as is directly to what we call web roles in Windows Azure, and we've made that very easy. So if you open Visual Studio and with a web application, you can, if you have the Windows Azure SDK installed, you can then just right-click on the application and say, I want to add this to a cloud project, and away it goes. It does all of the configuration stuff for you, and then you can just deploy it up into Windows Azure. And there's some great examples of how to do that online. I'll point you at some resources later on. I've got some cool websites to show you. It really is a fairly straightforward task. Now, there are some things you need to think about when you do that, of course. What dependencies does your application have on talking locally to I don't know, maybe file systems, maybe to other services in your network? You definitely need to take that into consideration. And there are a couple of options for that. One is, of course, that you can apply a thing called Windows Azure Connect, And Connect allows you to, when you run up a new compute instance in the cloud, as one of the startup tasks, you can create a tunnel, a VPN tunnel, back to your domain locally. And this VPN tunnel allows the Azure compute instance to access resources on your network as though it was part of your network, because in fact it is. It goes onto your domain as part of your network through a VPN tunnel back into your system. So that's the Connect piece is really good for that. And of course, some people are using Connect for really interesting things like having a picking system that runs in Azure but that prints into the warehouse, because you can just connect to a printer as though it was on the network, because that's what it is. It's on the network. So that's an interesting thing to do. Windows services that perform background tasks, we would normally think of as moving into worker roles. And the concept of roles is one that Windows Azure uses a fair bit. Roles are used to differentiate units of work or units of capability that scale independently. So, for example, if you have a website that perhaps accepts video submissions, and in the background what you want to do is resize the videos, re-encode them, perhaps take thumbnails and so on. But you don't want the main website to be down while that's happening. What you really want to be able to do is accept the video as quickly as possible and queue the video for processing later. And you can certainly do that. And the way you do it is you create a web role for doing the user interface for accepting the videos. And then you create a worker role, which you can scale independently to a number of different instances of that role in the background. And so when you get the video, you just put a message on the queue saying I've got the video, and you go off and accept the next video. And then the worker role in the back end, one of the instances of the worker role, which you might have many, goes to the queue and says, oh, what's my next thing to do? And it goes and picks the video off the queue and starts processing it. And then if it looks like you're accepting more videos than you can process with worker roles, that's fine. You just bump up the number of instances of the worker role, which you can do through the management interface, or you can in fact even programmatically do if you write that program yourself. So back-end processes we do with worker roles, front-end processes we do with web roles, and then of course there's all the bits in between around storage and so on. The Windows Azure storage, which is different from SQL Azure, and we'll talk about SQL Azure in just a sec. Windows Azure storage will allow you to store binary objects, and you can use it to serve out through a RESTful interface anything that you would normally serve up on the web. So scripts, you can serve out images, you can serve up videos, and so on. And you can even enable those storage pieces to be available on the edge points of a content distribution network. So while the Windows Azure data centers themselves are only in 8 locations around the world, 3 in the US, 2 in Europe, sorry, 3 in Europe, 3 in the US, and 2 in Asia. The content distribution network associated with Windows Azure has more than 25 endpoints, including one in Sydney, which means that if you are serving large amounts of data and you want to make sure it's available locally, then that's fine. You put it on the CDN, and it gets served from the closest endpoint to the consumer. Now it moves me on a little bit to SQL Azure. SQL Azure is interesting because it is a proper relational database as a service in the cloud, and it uses the standard SQL interfaces. It uses TDS to go and talk to talk to applications. So you can actually run an application locally, which connects to a SQL Azure server, as though it was connecting to any other SQL server in your data center or on your local machine or whatever. Because to the application and to the outside world, SQL Azure looks exactly like SQL Server. Now I've got a little asterisk there because exactly is an interesting concept. There are a couple of things that the SQL Azure does differently, and you need to be careful of expecting SQL Azure to work identically. One of the things that doesn't work identically is if you're using SQL CLR, that apart from the system SQL CLR data types, SQL CLR doesn't work in SQL Azure. That's the first one. The second one is that SQL Azure only uses SQL authentication. So if you're using Windows authentication, you've got to put a piece in there to allow you to do translation from your Windows authentication into a SQL authentication method. And thirdly, SQL Azure doesn't have a concept of four-part database object names, and so if you're using multiple schemas in SQL Server and you need to re-architect your databases. SQL Azure also has some limitations in terms of total database size, although we've addressed some of those with some of the sharding concepts in the latest release of SQL Azure. But at the moment, 150 gigs is the largest single database. Sorry, I'll start again. 150 gigs is the largest a single database can be. But you can actually add automatically. You can automatically shard a database across. Sorry, automatically shard a larger set of data across multiple databases, and SQL Azure will handle that for you. But you do need to opt into that sharding rather than have it happen automatically. The reason that that a single database can't be bigger than 150 gigs is because it's the way that the off-site redundancy is done is via a snapshot and a shipping of that snapshot to the backup data center, and 150 gigs is about the biggest we can do and still stay within our SLA around making sure that we have hot failover. Finally, if you're doing identity and you need to do it in the cloud, then you might think about the access control service. And the access control service allows you to do claims-based authentication into your application, either using one of a number of different identity providers. You can certainly do it through your Active Directory with Active Directory, the ADFS stuff, Active Directory Federation Services. There's a toolkit that allows you to do that in a fairly straightforward way. You can do it against a number of other things as well. In fact, you can have your application react differently based on which identity provider has been used to authenticate. So if someone logs into your application with their Facebook identity, it could take a completely different route through the application than if they logged in there through Active Directory Federation Services. And you might easily think that was a sensible thing to do, and there are plenty of architectures where that might be the case. Here are the resources I wanted to kick off with. The first one is the Windows Azure Platform Training Kit. Now, I've taken nearly 25, nearly 30 minutes to talk about a very, very high level, and I've literally only just scratched the surface. The Windows Azure Platform Training Kit. Let me see if I can show the Windows Azure Platform Training Kit. This is the September 2011 release I've got locally on my machine. The Windows Azure Platform Training Kit is very much a huge set of resources for learning Windows Azure and for training other people in Windows Azure. So it has some hands-on labs. It has a bunch of demos. Has lots and lots of sample code, presentations. Let's have a quick look at how many presentations there are. There are literally certainly tens, but maybe more presentations available in here. Each of these is half an hour or an hour's worth of presentation that you can review yourself or redeliver to your organization or to others. There are some videos, some introductory videos that are available through here that are also available online, and a set of prerequisites that get installed automatically that allow you to work through all the demos and samples and hands-on labs in your own time. So a very, very powerful piece of training, the training gear. Let me quickly duck back to here. So that the Azure Platform Training Kit, the easiest way to get that is to go to aka.ms and then /AU for Australia, AZ for Azure, and PTK for Platform Training Kit. If you want to sign up for a Windows Azure trial, then AU/AZ trial under aka.ms, and the trial account gives you 90 days of access to Azure, and certainly more than enough resources as part of that trial to do an assessment about how things are working and how they work and whether it's going to work out for you. The nice thing about the trial is that it gives you enough capacity to leave an instance of Azure running for that entire 3 months as part of that process, or it allows you to chop and change and add and subtract based on what your evaluation is like. If you're an MSDN subscriber, then you already get Azure benefits as part of that subscription. I don't know if you know this, but there's some thousands of dollars worth of Azure benefits you get as being an MSDN subscriber. If you go to aka.ms/auazmsdn, or just sign into your MSDN account, have a look for Azure benefits. Then you will you'll see that you can activate those. Depending on what level of MSDN subscriber you are, you get different amounts of benefits. If you're an MSDN Ultimate subscriber, then you get a whole lot of benefits. If you're a professional or whatever the other one's called, subscriber, then it's slightly less, but not significantly less. It's certainly enough to be running stuff on, and it's a great way of doing things. If you want to find out more about what's going on with Azure in the community, or be pointed at things as they come up, then my blog is a great place to look for that, aka.ms/coatsy, and that'll redirect you to my blog. And there's the other great place to look is the Windows Azure development portal on MSDN. So if you go to msdn.com/Azure, that'll redirect you to the Windows Azure Developer Center, which gives you access to details about how not just to do things in .NET, but also with Node.js or Java or PHP and a bunch of other things as well, because Azure is capable of not just running .NET applications, but a bunch of other things too. All right.
All right. Thank you, Andrew.
Yeah.
So I guess let's open it up for Q&A now. While you're thinking of questions, I'll ask Andrew a question. You mentioned the VM roles earlier. Could you just give us a bit of an intro on what the VM role involves and what we can actually do?
That's an excellent question. Thanks for bringing that up, Eric. That's a really good point that I did want to make. So as part of this concept of infrastructure as a service, Windows Azure has the ability to upload and run a VM. So basically, you upload a VHD file and kick off, and it runs up in Azure. Now, there's a few things at the moment you need to be aware of with that. One is that you don't want to be running VMs where on the system drive it's expecting to find it's expecting to keep state. And so there's a few applications that don't handle that all that well. So if state is kept on the system drive, then when we restart the VM, which we could do at any time based on a hardware issue or a load balancing issue or those sorts of things, you'll lose all that state. So that's something you need to be aware of. But if you've got something that you don't see as an easy, that's something that's going to be easy to translate into an application, a pure Azure application, it may be that it makes a bunch of sense to install that application on a virtual machine and then upload the virtual machine into the cloud and run it from there. Now, one of the reasons people used to do this was because they needed to run things with administrative privileges or install things with administrative privileges, and you weren't able to do that with Azure, with the web role or worker role. That's now been changed. So on startup, you can actually run elevated tasks. So, for example, if you have a service you need to install on the VM as part of that maybe you can use to do video processing, then you can certainly do that now as in an elevated role. Another thing people are doing is installing things like OCX controls that might be part of their back-end processing for applications, and again, you can do that with elevated privileges. Right. Coming soon, we're going to have a concept of state, and that is a thing you need to look out for in a release coming up of Windows Azure very soon. Before you jump in, Eric, there's one more thing I did want to say that I forgot to mention. One of the interesting things about working with Azure is that, unlike an operating system, a traditional operating system that ships maybe once every 18 months to 3 years, Windows Azure revs much more often than that, probably every quarter. And so we've got an opportunity to roll out features on a much shorter time frame. And you'll see that happening a lot, both in SQL Azure and in the Windows Azure platform. And so you definitely need to keep an eye out on what's going on with Azure for things as they appear.
All right, I've got a question here from Mehmet about what does state on a system drive mean when you're mentioning
cool.
a VM
That's an excellent question,
yep.
Mehmet. Yeah, cool, thanks. Often when an application is running, it'll write information to the system drive as it goes. So I don't know, SharePoint's an interesting example that it writes stuff locally onto the system drive rather than elsewhere, and also applications that database applications is another one that people often talk about. Whether can I just chuck something like MySQL up on Windows Azure? The answer is that yes, you can, but you need to be careful about where MySQL is writing its information, because if it's writing it to the C drive, essentially, what is essentially the C drive, then when we restart it, the C drive gets set back to nothing. So what you need to do is you need to mount a separate drive and write it to that instead, and there are detailed instructions about how to do that on MSDN and elsewhere, but it's just one of the gotchas in the VM role as it currently stands.
All right, great. Now, just before I ask Diane's question, just quickly, in terms of licensing, is that a minefield, or are you happy to answer questions about licensing as well?
Oh, if there's a license question, yeah, sure, I can.
Yep, okay, so related to the VM roles, Mehmet's just asking what licensing is covered by, say, I guess your different pricing models.
Right, so the VM role doesn't provide you with any particular licensing. It handles the host OS licensing, obviously, but the guest stuff is up to you. And so it depends on how you've already licensed whatever operating system you're going to put virtually. And not just whatever operating system, whatever other software you're going to put virtually. We don't provide you with any of those licenses as part of that process. So
okay.
You need to make sure that's taken care of.
Great. Right, so Diane Cook's got a question. What's your experience with using Azure with Microsoft Access?
So that's an interesting question, Diane. It depends what you mean by using with access. I'm going to ask a couple of clarifying questions, and perhaps you can unmute Diane.
Yeah, I'll unmute
Eric.
Diane now. Hopefully she's got a microphone.
A microphone.
Go
If you
ahead,
haven't, Diane, that's fine. You can just keep typing the question. Are you there? Okay, we'll assume that Diane's not got a microphone, and you can type answers to my clarifying questions if you like, Diane, and otherwise, of course, we can take it offline. The first one is, when you say running Access, do you mean running Access locally and talking to a data set in the cloud in Azure, and perhaps in SQL Azure? Is that the first one? Okay, so if you're connecting to Azure at the back end and you're talking about talking to SQL Azure, then it's exactly the same as talking to any other SQL server. You need to worry about things like latency, which you would have to do anyway in general, but it is literally a matter of connecting to a back-end data source, and whether that's running in whether it's a SQL server that's running on your local machine, or whether it's a SQL server that's running somewhere in your department, or whether it's a SQL server running in a data center for your organization, or a hosted data center somewhere else, or it's a SQL Azure instance. They're all identical. They all talk TDS, which is the Tabular Data Services. They all talk on port, whatever it is, 1433, and that just happens. You need to open up the firewall to do that, and that's as you would anywhere else. So in terms of talking to SQL Azure at the back end, that's an identical situation.
Great. Diane, did that answer your questions? Have you got any further questions? Okay, I've got another one from Damien. So Damien says, I understand Azure is a pay-as-you-go model, but is there a way of A, predicting costs based on traffic for existing sites and applications, and B, monitoring and potentially throttling usage?
So that's a great question, Damien. So yes to both is the answer to your question. The prediction stuff is we've got a TCO calculator that allows you to put in a fair bit of detail about your application and predict with a reasonable level of accuracy what it's going to cost you. We certainly are very transparent about what each of the components costs and how much you pay. There are ways you can pay and set a cap at your when you get to a particular threshold, and you can also say that there's also a whole heap of monitoring APIs available through a RESTful API that allow you to see exactly where you're at, both with your usage and billing each time. So that's all doable. The other thing I'd say is that if you've got a pretty good idea about what you're going to be doing, then you can move across to a subscription rather than a pay-as-you-go model, which gives you it doesn't give you unlimited benefits, but what it does do is certainly it allows us to pass on some benefits around the certainty that you're going to be paying at least this much, and therefore reduce the price. So that's another interesting way of looking at it.
Okay, great. Mehmet's got another question, just I guess on the business intelligence space, because I know Microsoft themselves are focusing a lot on business intelligence. So his question is, we currently have SQL and SQL reporting on Azure. Are we likely to see analysis services and maybe SSIS on Azure as well?
So it's a great question, Mehmet. My official response is I have no announcements to make at this time.
Okay. All right, great. So thank you all for attending. Hopefully Andrew's answered some of your questions about moving to the cloud. Just quickly before we wrap up as well, SSW have a few other courses that will be running in the next few months. And these ones are based on Microsoft's ASP.NET MVC platform. So there's a two-part series, building enterprise apps on MVC, so going beyond the demos. And in part 2, we'll be focusing more on enterprise technologies, so making them 500% more enterprisey. But we've also got a whole other slew of webinars and courses that we'll be running, so please check out our events page. If you're interested, or if you've got other topics that you'd like us to discuss, please feel free to shoot me an email. My email address is there, ericfan@ssw.com.au. So I'll hand it back to Andrew just to close off.
So folks, I'm going to leave you with resources, and as I do that, I'm going to leave you with one more thing that I'd like you to do. I'd love you to download the trial or activate your MSDN benefits and have a play with Azure. There are some great things you can do with Windows Azure. The trial or the MSDN benefits give you a friction-free, risk-free way of experimenting with it and seeing some of the things you can do. The best resource for learning about Windows Azure at the moment is the Windows Azure Platform Training Kit. There is an almost infinite amount of resources there for sufficiently small values of infinity, and I'd encourage you to grab it, have a play with it, and see what it can do. Please feel free to contact me. The best way to do that at the moment is through my blog, aka.ms/Coatsy, C-O-A-T-S-Y, or just do a search for me. You can Google me on Bing or Bing me on Google, depending on how you do it, and it should be fairly easy to find my blog. If you do that and contact me, I'll get back to you as soon as possible with some answers. Thanks again for your time, and I do appreciate SSW making this opportunity available as well. It's a great example of a trusted partner and an excellent partner of ours doing some cool things in the community, and I appreciate it. Thanks, guys.
Thanks, Andrew. Thanks, everyone, for attending. Hopefully we'll catch you at some other webinars and training sessions.